Hi girls, I'm just making this video because I'd like you to be aware of something that we have explored already in class, but some of you need a refresher on. And so that's modeling functions and experimenting with functions to see what variables do. Now, I don't want to get too close to the assessment task we are doing, because that would eradicate any sense of investigation that we're trying to achieve with that task. So what I'm going to do is model this function that you should be relatively familiar with, and that is y equals a on bx minus c plus d. And we're going to have a look what we're going to pretend we're exploring for the first time what variables like a, b, c, and d do in this function. So I'm going to go to a modeling program, and in this case it's going to be GeoGebra, and I'm going to use the app that is freely available to anyone. I'm going to use the online app, so it might be a little slow sometimes. So this is the GeoGebra Maths app, and it may be a little different to the one that you would download and use, but essentially it's fundamentally very similar, and very similar of course to Desmos as well. So what I'm going to do to explore this, to model it effectively, I need to have sliders, and here's a slider tool up here. I'm going to make my first slider. If you remember, I had A, B, C, and D. I'm just going to grab the keyboard at this point. So I want a slider, I select the slider tool, I click anywhere in here, and I'm going to make the slider A. I'm going to make slider B, make slider C, and make slider D. I don't need to change anything particular. They will function, they'll go from -5 to 5, and they should have an accuracy of hundredths. So I've got my 5 sliders. Now I need to type in my function that I'm working with, and the function I'm working with, if you remember, was y equals, now I want a on b times x minus c plus d. There it is there, that's where it appears. A on b times b times x minus c plus d. And let's just flick back again. Is that what I had? A on b times x minus c plus d. And you'll notice that when I did it online, I did have to make brackets around the bx minus c. Those brackets weren't on the function. I needed to put them in so that GeoGebra knew that was one item. Now occasionally little eccentricities like that do occur, where you must put in brackets to understand how to take a function from paper and put it onto a ICT, integrated computer technology. So there's my function. To make it the parent function, that is the base function, some of these I'm going to have to set to 0, and maybe b can be 0. Would that be right? B being 0. And no, b would have to be 1. Sorry about that. B would have to be 1 because it's in front of the x. If I make it 0, it disappears entirely. Make c 0. Come on. And we'll make d 0. Some of you may know what that is. It's the parent function. And by parent function, I'm just going to flick away again briefly. By parent function, I mean what is the most basic form of this function. And if we look at this one here, if we set a to 1, we set b to 1, we set c to 0, and we set d to 0, we end up with this function y equals 1 on x. That's this function, this hyperbola function's parent function. That is the most basic form of that function. The sliders which we're applying, the sliders which we're putting in, alter the parent function, and our job is to find out what do those sliders do. And so by themselves and then in combination I will just play. I move the sliders around and I see what happens, and I try to work out what are the important things I'm making that slider do. For instance, when the slider is greater than 1, when the slider is in between 1 and 0, when the slider becomes negative and greater than -1, or less than -1. Then I might experiment with B as well. What does B do? And if it's in combination with A, what does they do together? Now along the way I might make some notes. I try and make them as clearly as possible. I try and use the mathematical language that I've been taught. And I try and use mathematical language that is appropriate for the function that I am using. Now in this function, because it's hyperbola, I might use terms like horizontal translation, vertical translation. I might use terms like dilation. Are they the same terms that are going to be appropriate for your exploration? Well, usually there would be some clue as to what the appropriate terms are. Read carefully through your assessment material and give us any feedback. Thank you, girls.